Good morning, good afternoon, good evening, wherever you're watching this from. My name is Debrup Ghosh, and I'm a product manager in cybersecurity. This is my assignment for the machine learning foundations for product managers. So let's start and talk about the problem. So in this data set, we can see that there's temperature, exhaust vacuum, ambient pressure, and relative humidity as the four main variables. And what we are being asked is to look at the net hourly electrical energy output, the PE over here. That is the target variable. So it's a fairly standard data set, about 9,500 readings, and it's not a large data set. The other thing that they asked for in this assignment is use a ML model to build a regression problem. So in this case, I'm actually using Python. We can probably do this in Excel, but I feel more comfortable in Python. One thing to note is Google AutoML. I think Google has merged this into Vertex AI now, and the pipelines failed, and I was not able to do it in AutoML. So yeah, fairly straightforward. So let's dive into some of the exploratory data analysis. Now, what I really like to do when I have some data is start off by looking at the macro picture. So what is interesting over here, this variable over here, 80, like it has two peaks, right? Like it's very interesting what's happening over here. Same goes for vacuum over here. Like you see one peak over here in terms of the number of readings, another peak over here. AP, this is quite interesting. It's almost a bell curve over here, so that's interesting. And then relative humidity as well. This is a skewed bell, more toward the 90th percentile. And then when we look at this being the target variable, the PE, this still again has two peaks, but this is really all over the place. So what I also like to do when when I'm doing this is look at what are the what are the relationship between the variables. So if you focus on the bottom of my screen over here, this PE versus all the other four it's captured over here, as you can see. So clearly we can see that with the temperature, there is a strong negative correlation, which means the graph is going down, from the top to the bottom, right? Similarly, over here for exhaust vacuum, we can see that the power output decreases as the vacuum increases. Now, ambient pressure and PE, this is pretty interesting. 0.5 is pretty low correlation, right? So and some of that is actually explained with this chart over here. Like it's a fairly interesting bell curve. And then relative humidity is 0.39, which shows that once again there is a very weak positive correlation over here. So just to back up this story, what you will see in this scatter plot is for vacuum and temperature, it's pardon me, it's going down. But then as soon as you start plotting AP, which is the ambient pressure and the relative humidity, like it's really all over the place. If you follow my cursor over here, it's really all over the place. So that's what I think makes this problem pretty interesting. So let's talk about the modeling approach. It's pretty straightforward. We talked about the goal, which is to predict the net hourly electrical output, energy output. We use the variables available over here, and then we actually applied four algorithms: linear regression and random forest. And I was quite curious to learn, how do you make a linear regression better? So I used the support vector regression and gradient boosting regression as well. Lot of text on this slide. I apologize in advance. So linear regression, it's a pretty fundamental model. That's why we chose it. Random forest, as we learned in the course, like it can take in a lot of complex relationships. So we use that, and then the two other more advanced regression models. This was me just trying to figure out how can we make the model better? How can we improve the linear regression? So in terms of model building, once again, nothing fancy over here. We looked at the training set, about 80% of the data, the test set, which was about 20% of the data. And we used a five-fold cross-validation to evaluate the performance of each model. In terms of model evaluation, we looked at the mean squared error and the R square. The mean square error gives a really good indication about the prediction accuracy, and R square captures the variance. So let's look at the results, right? I think that's probably the most interesting thing over here. So linear regression, we get a very high R square of 0.93. But we see that the cross validation mean square error is higher than the test. So that shows there is some overfitting going on over here. Random forest, really good R square, and then very minimal overfitting. So that's really good. And these two are basically just building off the linear regression model over here. You will see that in this case, the R square slightly goes up. But overall, we see that the random forest is the best model and with the highest R square. So that's it from me. I hope you enjoyed this video and look forward to talking to some of you soon.